This EDEM tutorial focus on the long-range electrostatic force and tribocharging capabilities of EDEM. Start by setting the units for the simulation. Next, add a bulk material and rename the material to toner. Define its properties and interactions. Create a single sphere particle and rename as toner particle. Set the radius of the sphere and calculate its properties. Next, create two different equipment materials and name them accordingly. Set the materials' properties and interactions for both rollers, and add the work function value for the top roller. Next step is to define the physics. Choose particle body force interaction and select the electrostatics model. Next, you must define the screening distance. Under the particle-to-geometry interaction, enable the tribocharging model that handles the transfer of charge due to the triboelectric effect. Set the alpha value to 0.1 to obtain the desired charge distribution. Next, import the roller's geometries and name them accordingly. Please note that the geometries have been meshed to a resolution suitable for this electrostatic simulation. Next, specify the charge value of the rollers. The toner particles should be attracted to both the magnetic roller and the top roller. Select electrostatics from the expanded options. Add a small positive charge to the magnetic roller. And ensure that the Exclude from Electrostatics Calculations box is unchecked. Repeat the same steps for the top roller and set the starting surface charge value. Next, you must add a linear rotation kinematic to the rollers. Add an initial velocity and specify the axis of rotation. For the top roller, set the initial velocity to 25 rpm and specify the axis of rotation. Next, create the particle factory geometry. Set the type to virtual, as it is not a physical part of the equipment. Define the dimensions and position for the factory. Then, add a dynamic factory to generate an unlimited number of particles. Set the generation rate and assign a fixed velocity to the particles being created in the x and z directions. Finally, ensure the charge option is set to fixed, and add the charge parameter value. Move to the Environment section and select Boundary Conditions. Select the Y option in the Periodic Boundaries section to prevent particles leaving the domain in the Y-axis. Next, move to the simulator. Set the simulation parameters, including the time step, simulation time, and the target save interval. Set the cell size. We are running the simulation using the CPU solver. Once your simulation is complete, move to the Analyst. The display section in the Analyst tree is used to configure how particles and geometry parts are visually represented in the simulation. You can experiment with different visualizations and coloring options. Color the particles according to their electrostatic force, assigning colors to represent the minimum, medium, and maximum values of electrostatic force present on the particles. Check the auto-update options for both minimum and maximum values so that the values update as the simulation is being played. Experiment with different attributes for both geometry and particles. For example, try coloring the top roller geometry by charge. Next, plot the charge values for the top roller over time. The graph produced shows a decrease in the charge on the geometry.